All right. Welcome to the last session of the process mining school. My job is to introduce Marlon. But before that, I would like to highlight that this contribution sets a lot of records. So, for instance, it is in terms of words, it's the shortest title, robotic process mining. But in terms of letters, it is actually the shortest title we have. Furthermore, it's also the contribution with the highest number of co-authors, out of which one, of course, is Marlon, and he's gonna tell us something about automating very repetitive tasks, like, for instance, kicking drunk students out of private parties or correcting exams. Marlon?
Thank you very much. No, I'm not gonna tell you how to automatically grade exams. You still have to do them after the summer school, you know. Thank you very much for the intro. It's a pleasure to be here in this summer school. I want to share with you some perspectives and advances in the area of basically automation, but not automation of end-to-end business processes, but automation of individual tasks in business processes using robotic process automation technology. I call that mixture of process mining and robotic process automation, robotic process mining for short, for good or for bad. Don't take the term very seriously. It's just a way of combining those two terms. Maybe it's a good idea to start by basically summarizing what we have seen in the summer school in the past 4 days, 4.5, right? So we set the scope that allows me to say what I'm going to be talking about. So first, essentially what process mining does is that it takes data from enterprise systems, most of the times, packaged enterprise systems, CRMs, ERPs, SCMs, incident management, service management systems, for example, and it extracts them through some sort of extract, transform, load procedure, you know, where you do a lot of data processing and data transformation, and it puts it in some non-first normal form table, which we call an event log. And from there, we basically can do 5 different things. You can extract 5 different types of outputs via process mining. So the first type of output that you can extract from an event log constructed from the data in an enterprise system or in several enterprise systems is some sort of process map or process model. And that's very useful for exploratory analysis of the process, understanding the pathways in the process and deviations and so on. And it also extracts process performance measures that you can visualize in many different ways. You know, arguably, this is something that could be done in many cases using also business intelligence tools. But the fact that you then combine those process performance measurements with the process models that you discovered in the previous step is very valuable as well, because you can see the performance of the process in the context of the process model. On Monday and Tuesday, we saw a lot about the process model part. How do you get process models from those event logs? On Wednesday, Massimiliano De Leoni talked to us about process performance measurement and how that can be combined with process models in order to get so-called enhanced pictures of your process. Then on Monday and Tuesday, we also heard about a third output of process mining, which is conformance report. How you can take a set of business rules or possibly even an end-to-end process model, and you can compare those business rules or those process models with the event log, and you can get all sorts of conformance reports. And that is very useful in many applications, including auditing, as we saw in the presentation just before mine. And finally, fourth, you can extract from a process model comparative analysis reports. In practice, this is perhaps one of the most important artifacts from a practical angle, as we saw in the presentation by Lars. That's basically the message he was conveying. That process mining allows you to compare, for example, the cases where your customer complained versus the cases where the customer was happy, or the cases that were on time versus cases that were late, and from there to derive insights that lead to actions for changing the process. And that's essentially, from a, if you turn it into from a theoretical perspective, the theoretical counterpart of what Lars was saying. And, compare, use process mining to identify insights, root causes into your problems that you can turn into actions. And finally, process mining can be used to look forward in your process, not only to analyze the as-is process, this is how the process currently behaves, but also to project yourself into the future in at least two ways. One is by allowing you to build simulation models from data to answer what-if analysis questions, like what will happen if I get twice the number of purchase orders next week relative to what I have got in the past 2 weeks? What will be the impact on the waiting times on the SLA violations that I get, right? So that's a very big aspect of process mining. And also, last but not least, what we saw yesterday, Chiara presented here, Chiara Di Francesco Marino was showing how you can exploit the same type of data that you use for descriptive process mining. You can also use it to generate models to predict the future within the as-is process. The difference between data-driven simulation and process prediction is that data-driven simulation allows you to predict the future in a to-be context, or in a what-if context. What if I do this? What if this happens? Whereas predictive process monitoring generates process predictions, the opposite, in the as-is context, assuming that the process does not change and the environment of the process does not change. And they are quite complementary. And you take those 5 things, and that basically gives you what process mining is about as far as outputs is concerned. All of that is made possible, all those 5 classes of outputs are made possible because we scope the reality to one or several processes that we want to analyze, and each of these processes has a start and it has an end. And if you observe the data in the past, you can group it into traces, where every trace is one execution of the process, also known as a case. And you can then represent that in a very simple, flat representation, where you have a table where every row represents some type of action, activity, event that happened in the reality. And for every such row, you have an identifier of the process instance where it happened. You have a timestamp when it finished or when it started. And you have a description of that activity. And then you can have as many other attributes that give you an idea about the context in which things were executed, or about the details of the action, what happened inside. So that is just to, I haven't even started my lecture. That is just to set the ground where I come from. So in that big map, fantastic map of what you have seen in this week, I'm going to talk about a little dot somewhere there that you could even overlook very easily. So when I extract data from an enterprise system, usually the events I get are events that are major activity transitions. For example, a user clicked on submit PO, and then a record was created in the ERP system, with the purchase order and all its glorious details, right? Then in the enterprise system, you might not see anything until some automated system checks the inventory and records another event called inventory checked, for example, and moves the object to a new state. But a lot of things might have happened in the meantime. And you don't see that reality in the middle. So in a parallel, each of these, so you can see at a very high level of abstraction, and by removing lots of stuff, you can see that an event log contains traces, each of which contains a case identifier, some timestamps that allow you to give an order to those activities in the trace, and then it describes how the process was performed in terms of tasks or major transitions in an activity. In parallel, in a parallel world, let's call it, there are people doing work. And they do lots of stuff. They are working possibly on some other processes, yeah? They are working on some, they are maybe not even in the company. They are maybe doing tasks that are not digitally recorded, right? But let me focus on what is digitally recorded, and that's why I use interactions with the IT system. So I'm not claiming that we see everything that the workers are doing, but at least we see the interactions with digital systems, or we are capable of observing the interactions with digital systems. And they can be of different types. I can just be reading an email. I can just be doing something private, like, you know, posting a picture on Snapchat, right? That's why we saw responsible process mining, because we are dealing with event logs of workers, and they are doing private things in the middle. But all of a sudden, they open a Salesforce system and an SAP system, and they do some work. Yeah. So some of these interactions, so if you could observe all the interactions that your workers are having with their desktop applications, their browsers, and all the digital interactions that they are doing, you will get for every worker in your organization, you will get a very long trail of interactions. I'll call them UIs, user interactions. UIs not for user interface, but UI for user interaction. So there are lots of UIs. And occasionally, some of these UIs are connected with the tasks in your process. God knows which ones. Some of them are connected, some of them are not connected. For example, assess the loan application might involve the loan officer receiving some notification via email, then or in a task in Outlook, and then they clicking it and they opening a PDF report of the loan application in Adobe. And then, of course, they got a message in their phone, and they went and, you know, looked at a picture that somebody posted on TikTok. I think on TikTok you don't post pictures, right? You post videos rather, right? Okay, so, and then you like the TikTok many times, okay? That is private. That is private, and that's why what you know, we heard yesterday is so important, right? I mean, we don't want to see those TikToks when we are doing process mining. It will distract us too much, okay? So, and then they go to Salesforce and they do some real serious work, and they go to their lending backend, the lending application, and then to Outlook again to mark the task as completed in Outlook. Yeah, and that's how that task. That's what we see of that task. It can actually be more detailed. You can actually know where exactly in Salesforce they clicked, which screen they were in Salesforce, what exact field they clicked. You can go into a lot of details. Okay, so if all I have is the data from the enterprise system, I can analyze the upper part. Very nice. Now, I'm going to talk about what is made possible if you could get hold of this lower trail of actions or interactions, digital interactions that are happening in your system. So if I could get hold of them, for each of them, I will have a worker ID, a description of the action, lots of other attributes about the action, including maybe data that was read and written, and I could look into more details into where people are actually spending time. What are they actually doing while they do the work? And if I could that would be great, because I could get deeper insights into why certain tasks are taking longer. It might be that people have bouncing back between different screens or different systems, and if only I could know it, I could maybe improve the work instructions, the procedures, and give more streamlined procedures so that my workers don't need to bounce back between systems. I could redesign the UIs of my enterprise systems, build new integrations so that, you know, this PDF file doesn't need to be open here, but the person can go straight from Outlook into Salesforce, and Salesforce will have the data in that PDF file. I could do that integration to happen it, and not only I will merge these two tasks into one and it will be faster, but I will perhaps get rid of the TikTok. Maybe the TikTok can happen after the Outlook instead of during the performance of the task. Right. So let me assume that I can record what the workers are doing. And then for every worker, so I don't show the worker ID here because I assume that this is a recording of one worker, and I have many of them, yeah, for every worker. I have the recording of what they did in an entire day, all their digital interactions in an entire day with their main workstation, let's say their laptop. And I know at which time they clicked a button, on which application, maybe even which tab they had opened, what is the title in the web application, which element they clicked, is it a field where they positioned in a drop-down menu, etc., and what was, if they typed something or if that field in the web form contains something, I can know the content of it. So let me imagine I can extract that, and this is not impossible to do. You know, you can do tools that extract these kind of things using the Windows API, for example, for Windows, or some tool vendors are a little bit crazy. I hope they are not here. They take screenshots and they do image processing, which is a little bit of a far-fetched thing to do. First of all, because it's extremely difficult to render that data private. So somewhere you will see something about my TikTok, and well, TikTok's not a problem because you publish them anyway, right? Yeah. So and then you will have whereas if it is structured, you know, at least you can use some of these techniques we saw and do all sorts of anonymization with it, you know, using techniques that give you certain guarantees. Anyway, let's assume I got this thing out. One of my problems with that is that event, that trail I show you, this trail, doesn't say absolutely anything about in the context of which process or task or case ID this happened. I have no idea where this action, where it belongs in my processes. And this person might be working on 10 processes, on a given day or hour on 20 different cases. I have no idea what this refers to, right? Okay, no panic. There are some, so basically the UI logs is clear. If I want to use them together with my event logs in some way, I need to do something called segmentation. You know, I need to be able to say, here, an instance of a task, the worker started working on an instance of a task, and here they finish working on an instance of a task. And here they started working on the next instance, and here they finish working on the next instance. So I have to segment the event log. And also, if possible, every one of these task instances, ideally, wouldn't it be great if I could correlate them with some case identifier, so that, or with a task instance identifier, so that I know specifically in what case of which process this happened. So this happened as part of the activity assess application of case ID number 2527 of the loan application process. That would be fantastic. So you can be very pragmatic and say, and this is what people do, like vendors who do, they will say, well, if usually there will be an event that really says you started something. So think about creating a purchase order. Yeah, you go to your ERP system, and there is a menu or a button that says create new purchase order, right? So when you click on that, you start an instance of a task, create purchase order. And there is a button called submit purchase order or save purchase order. And then when you click on it, then you completed the task. Yeah, yeah. So then it's very pragmatic. Yeah? And then it says, okay, so I need those events. Okay, and I'm a tool vendor and I need to ship my product. And then what is my solution to the problem of figuring out what the delimiters are? How do I figure out where does what buttons signal the start and the end? You ask. Yeah. So you ask the user. So which events signal the start of a task and which events signal the end of the task? And then they tell you. Yeah. Boom. So very pragmatic approach. So that's what I call the delimiter-based approach. You ask the user, give me the delimiter, and I will find it. And then you take this long trail of interactions of a worker, and you find starts and ends of activity of task instances in there. Yeah. In some of those events, yeah, like for example, when you create a PO, in the next screen, there is a field that has the PO identifier because it was automatically assigned by the system and is displayed. And then you ask again the user to point out to the field that in an event that allows you to relate that event with a case ID. So you say, hey, this field here gives you the purchase order identifier, and you use that information to find the case identifier as well. So you ask the user to give you the data, the user nicely gives it to you, to the tool, and the tool then goes and divides things into task instances and takes it off. There is another very, very nice trick, which is, well, hey, I have an event log, and if I am lucky, the event log has start times and end times. If I'm not lucky, ask Massimiliano. He knows how to find the start time, isn't it? Yeah? Yeah, okay. So he can tell you where to find it. So imagine you have a log with start times and end times. Then for every instance of a task, you know when it started, when it ended, and who did it. So you go to the UI log, you take the date when it started, you take the date when that task instance finished, and all the events in between belong to that task instance. Boom, including the TikTok thingy. Yeah. So those things belong to this task instance. And by the same token, because you know to what instance of task they belong to, you also know to which case ID they belong to, and you won. So some vendors are doing this resource time windowing for segmenting UI logs. Yes, so the ability to record UI logs, like to put a probe, we call it, in the desktop of the workers to record their activity during a certain time, and to enable a user, an analyst, to give you some input that allows you to segment and to correlate the events in the UI log. That's the core of a certain type of tools that are called task mining tools. That's the core of what they do. They install probes in the deployed user workstations. They gather user interaction data. They push it to a data processing server. The data processing server has a console, like a screen, where an analyst can specify like markers or delimiters for when tasks start, when it ends, and positions of case identifiers on the screens. And they specify it in some nice UI or not nice UI, depending on the tool. And the tool then pre-processes the data, segments it into task instances, correlates it to case identifiers where available. Also, in those tools, you can specify that certain types of events should be discarded, like the TikTok one. So you say if a visit to a website that is not in our domain, for example, is discarded. So any event on the browser where the URL in the address bar is not in my company, then probably private, so I throw it out. And then maybe I do other tricks to get some further privacy for my workers. And I send it, then I get a table of user interactions like the one I showed you before, but now correlated. So you know every event to which task instance it belongs, and possibly even to which case of a process it belongs to. And you then throw that to a process mining tool or to a business intelligence tool for that matter. Click Power BI, and you start doing all sorts of dashboards, and you might discover a process map out of these user interaction logs, given that they are segmented. Because a process mining tool, if the thing is not segmented, cannot do anything. Yeah? It needs to have traces. Yeah. So given that you have instances of tasks, and there are task IDs, you can say the task ID is the case ID, and you can give it to your favorite process mining tool. I will not tell you what my favorite process mining tool. You will guess it. You give it to your favorite process mining tool, and then it shows you this is an instance of one task performed by a person, and this is at the level where the events, where the activity label is the action, like get cell, click text field, paste, edit field, click button. This is the execution of one relatively complex, mid-complexity task in a real-world setting. And it has 810 steps. Gosh, that we click so much. Who clicked that much to perform one task? But actually, in real life, it's not a big deal. I think I clicked more to prepare my slides yesterday. This is, you will agree, use less. Use less. Okay. So displaying click data on a screen in simple settings. When I do a demo, by the way, if I was doing a commercial demo for you, I will tell you this is great. So when you do a simple example, it's fantastic. You see the list of clicks, and you can see, oh, here the person deviated with respect to best practices. You know, instead of clicking here, they click there, blah, blah, blah. In real life, what really is useful is when you don't use the action as the activity label, but you rather use the screen name, yeah, as the activity label. So if in a browser you have a title in the address bar, right? If you are in Excel, you have a title in the document, or or even at the level of the individual sheet, and then you can do something like this. I call it a screen level task mining. Task mining log, and then you display a process map of it, and then you can see how people, while they perform a task, let's say a claims assessment task, they are jumping from the CRM to Outlook, back to the CRM, then they go to Teams, then they go to the claim management system, they go to a knowledge base, to the CRM client's screen of the CRM system, they use Notepad, whatever. Yeah? And then you can see how they are bouncing back between different applications, all their context switches, and all the times between these context switches. And you can say, like, oh, this bouncing between the document management system, DMS, and Notepad is taking 30 seconds. It looks like, you know, people are struggling to compose something they copy from the DMS, and it turns out that this DMS is very bad. You cannot copy-paste into it straight into some document that you need to fill in. So what people are doing is that they are copying it into Notepad, and from Notepad, they copy it again, so that it's only text only, and it doesn't have format, so that they can paste it somewhere else. And then you say, okay, I have an opportunity for improvement there. So this is basically one of the things that people are calling task mining. So they put probes, they give delimiters and hooks to segment and to correlate the traces, the events at the level of clicks or screen visits, to correlate them back to task instance identifiers or to case identifiers, and then they get a segmented log consisting of a set of traces that they can load into a process mining interface or a business intelligence interface and do all sorts of nice dashboarding. Right, so task mining is essentially that. I didn't really define it, but it's about recording workers' work, segmenting it, correlating it, and analyzing it using different tools, process mining, dashboarding tools, etc. It differs from process mining because in process mining we are trying to optimize end-to-end processes so that the time frame of what we optimize is larger. So we don't optimize stuff that takes 20 minutes. We optimize stuff that takes like 10 days. We don't optimize things that are performed by individual people or by 2 or 3 people, but we optimize things that cross across many departments and silos. Task mining works at the level of tasks, of course. We optimize against end-to-end KPIs, process performance indicators. Task mining, you optimize against task performance indicators. And the sources of data are different. In process mining, the sources of data are enterprise systems, ERP, CRMs, SCMs, etc. In task mining, you are working with user interactions recorded typically on desktops of workers in your company. And another difference is in the process mining, from the data extraction, we are already extracting one or more case identifiers, as we saw with Dear Fachland, sometimes it's many, and we use that in order to do our grouping of events into traces. In task mining, the raw data we get doesn't have that. It's just like a big recording, like the recording of my presentation right now, and then you have to segment it in some way into instances of tasks that are being performed. But it's possible to do it. Right. There are many applications of task mining now. If I look at the applications of task mining, typically classified into three areas. One of the big impact, let's say high impact uses of task mining is for workforce optimization, where effectively you want to find best practices, like workers that are performing better, and you want to learn from how they do the work in order to basically derive best practice instructions to give to other workers. Yeah. So you are trying to make your workers more efficient by learning from the ones that are performing better and showing to the others, this is how you can do this task more effectively. Of course, you can also improve the performance of individual tasks. So you can look at how the task is performed, and you saw that I see that there are some back and forth between different screens. So to improve a task, I could reorganize a little bit the data, the work, and so that users can work on a single screen, instead of having to bounce between 3-4 different screens. That's called task optimization. Why? Because I'm not looking at how an individual worker is working relative to others. I just look at generally how a task is performed, and I try to identify reworks and bottlenecks and overprocessing that I can then use to perhaps change the task instructions or change the user interfaces that users of that workers are using so that I can do that task more efficiently. Today, I'm going to talk about the third use case of process mining, which is task automation. So you can use these UI logs in order to identify and exploit opportunities for automation that then speed up the tasks, reduce labor effort, possibly reduce cost, etc. You can automate in many different ways. You can use you can automate at the level by integrating at the level of APIs, for example, different systems, and putting in orchestration engines on top of that. I'm going to talk more specifically about tasks that are amenable to automation via a class of tools known as robotic process automation tools, as opposed to all the other possible automation technology that you can use. Of course, many of the things I will say could also be used to automate using other automation technology. So that's going to be the focus of my talk. So finally, I can start my talk now. I hope it's still 10:15. Yeah, but probably it's 10:30. Wow, only 30 minutes to start. Fantastic. So I'm going to talk about how process mining can be applied in the context of RPA. Quick definition of RPA, but many of you know RPA is like a technology or a class of techniques and tools that allows organizations to automate repetitive clerical tasks, particularly data transfer routines. Yeah, that's the main use case is where data needs to kind of move from one system or silo to another system, and people are actually doing work on top of screens to do that data transfer. Yeah. So for example, entering grades. If you are in an academic setting, like entering grades, you nicely put them together in some spreadsheet for yourself, and now you need to enter them one by one into a system in some way. It turns out you don't have it in a format that you can just upload it, and your data is dirty, so you start doing stuff manually. So There are two types of RPA. Attended means the RPA, the RPA helps you, which means if you reach a point where, oh, now all the rest is repetitive, you click a button and a so-called software bot does it. And unattended is when you have a software bot that performs an entire task by itself. For example, you receive a certain type of email with a certain type of attachment. The bot grabs it, it extracts data from that spreadsheet, and it pushes it into some enterprise system in some way. So that will be unattended. I'll be talking mostly about unattended automation today, in a way, full automation. But some of the things I'll say, I'll give pointers to where it could be used or extended to do attended automation as well. So the type of tasks that we will be looking at, of course, RPAs are broader than that, but as I said, many of the work that RPA tools does are data transfer routines. And data transfer routines basically boil down to taking data from one or more screens or sections of an application, like a spreadsheet in Excel, and pushing it into a web application, for example, creating a new record in your Salesforce system, and then pushing on the submit button. And I'm gonna already hint how this can be done by so basically what will happen, what is happening here is that on the left-hand side, I have fields with data, and what I'm doing it is to take either the entire fields and pass it to another field, or sometimes to break down a field and pass it to multiple fields on the other side, or to merge multiple fields into one. So that is intuitively a big class of tasks that RPA is automating. I will claim that 80% of what RPA is being used for is this type of routines, I will call them, data transfer routines. So robotic process automation is very useful in the context of automating data transfer routines because it reduces the error rates, it decreases cycle time because it decreases processing time, so it's done by the machine instead of done by a human. It allows you to be more consistent, so you consistently copy all the data and you don't leave some fields not copied because a human being can get tired and say, oh, this is not important, cannot copy it, and then later you have a data incompleteness issue if you want to do some types of analysis. And last, and don't blame me for that, it can also be used to reduce costs by, we call it reallocating resources. Yeah, we don't call it firing people, okay? So there are some ethical issues about introduction of RPA in organizations and the implications on the people in the organization and the broader societal implications of automation. That's a fantastic item, but a very, very important consideration. And if you want to know more about it, it's better to talk to somebody who knows about ethics. Yeah, I practice ethics. I do not know about it. Great. So classically, for RPA, one of the many activities, but core activities in setting up RPA in an organization is to develop software bots. And there are loads of people out there who are developing software bots or finding opportunities for developing software bots by effectively observing interactions between users, workers, and IT systems through the screens, analyzing them through interviews, through workshops, so, observation studies, and shadowing, work shadowing, and they specify like a blueprint. We should automate this routine, and then they give it to an RPA development team. They have a few back and forth, and the RPA development team develops a bot. In this development process, RPA development process, robotic process mining, what it attempts to do is to reduce potential errors in the development and to get more complete picture of what can be automated by recording those interactions, as we showed before, like we record how the workers do their work on the desktop machine and we extract UI logs from it. these UI logs are then used to automatically discover routines that could be automated, so candidate routines for automation. And of course, candidate routines means it potentially automatable, but not necessarily worth automating or not necessarily a high priority for automation. Then there is a bit of analysis that can be done on top of it to prioritize these routines and say which ones are we going to develop. And in the second leg, instead of in addition to having developers doing the development of the bot, robotic process mining can help you to identify those routines that what is the automatable part of a task. We call them automatable routines. And out of those automatable routines, synthesizing a software bot or a skeleton of the software bot that the RPA developers can use as input to, and then refine to get like the final bot that they will deploy to automate a given data transfer routine. So essentially, robotic process mining is the bottom part of this. Is about identifying from a user interaction log routines that are candidates for automation in a way that potentially you might want to automate, determining to what extent these routines are automatable, so can you fully automate them, can you partially automate them, etc. And for those subroutines that are automatable, robotic process mining seeks to automatically discover the routine script in an executable format that you can then run in an RPA tool, and you get a software bot out of it that is able to do the routine that you observed in the UI log. And bear in mind that I'm talking about taking as input as a UI log, a recording of what 1 or 10 workers are doing over a period of an entire day. So that's the input I take. I take UI logs, which are typically 5 to 50 million type of records because they are very detailed, of maybe even 10 different workers, and then I try to find what can be automated in there, and I try to display that to the user and then to discover executable routine specifications out of it. There are, in this field of robotic process mining that seeks to identify and automate routines out of UI logs, there are many open challenges out there. I classify them into 4, but it's an arbitrary classification, and there might be many more research questions worth working on. I will focus on 2 tasks, on 2 of these research questions, but the other 2 are equally exciting. The first one is, given a user interaction log of 1 or several workers, recording their activity during many hours, say, 300 hours, 500 hours of recording. Out of that, I want to identify repetitive data transfer routines specifically that can be automated via an RPA tool, and I want to be able to assess to what degree they are automatable. Yeah? Because routines can be automatable in the happy path, but then when there are exceptions, it's not automatable. The exceptions are not resolved in a deterministic manner, so we cannot automate them. So it might be sometimes that a routine is partially automatable. And the question is, to what extent a routine is automatable? If I automated it using RPA, what is the maximum amount of reduction in processing time that I can get? Say that the routine currently takes 30 minutes. Can I bring it down to 10 minutes on average? Or can I only bring it down to 20 minutes on average? What portion of the routine could be accelerated with RPA? Second, given a UI log, again, given a routine, so one routine, and given the UI log, but only for those instances of that routine, not the rest. Now I'm focusing on a segment of the user interaction log. How to extract an executable script that an RPA tool can execute and that automates that routine. Possibly to the maximum possible extent, because sometimes it's not fully automatable. And when, of course, then when it cannot continue, when it gets stuck, I have to have a mechanism for, that the bot should have a mechanism for saying, I cannot continue. I reach a state where the rest is not automatable. Yeah? So I need that out of this bot that I am synthesizing. How can you do this? So we, I'm sorry, but I'm already midway, I assume. So I have been talking about more general, and I'm exactly at 11:30, that's exactly midway. So I am allowed to talk about my work now, right? You know, because I know that some people were saying that Felix's talk was so great yesterday because he didn't talk about his own work. He talked about the field in general. So then that put pressure on me, and I say, well, at least I have to spend half of my talk talking about the field in general before I talk about my work. So, but now it's 11:30, so I can. Great. So, so this is our proposal with the bunch of authors you saw of how you can tackle this problem. It's a bit overwhelming because it's a mixture of research problems with engineering problems, but let me unpack it for you. So we have a UI log, and it records 500 hours of 10 workers working on their daily work. And I know they work on some process, some tasks or some processes, but they are just doing their daily work. And I need to use it to identify routines that are amenable to automation within their daily work. So the first thing is to try to segment it into instances of tasks within which I can find logical units that can be automated. Yeah. So the hypothesis I'm making is that it's within tasks that I will find repetitive routines. So I need to segment it, in essence, into task instances. Then I get task traces, so a collection of executions of tasks. Then there is a lot of noise in there, as I will show you. There is a lot of interactions that are redundant. Yeah, a lot of when we are using Excel or PowerPoint, or we are doing something on the browser, we not always take the shortest path to things. We sometimes do things that are redundant and could be done a little bit more streamlined. So we try to identify those interactions that do not have an effect on the routine at the end of the day, or that are redundant and that I can eliminate. So I come up with a simplified task traces where I drop redundant stuff. And then the magic comes. We try to identify in their routines or sequences of steps that are very repetitive and that are taking a big chunk of work. Yeah, sequence of steps that are probably data transfer routines and that are very frequent and that in total are taking a large amount of time. And those things, I call it candidate routines for RPA. They are candidate because I don't even know if they can be automated. Yeah? I just see that they are repetitive. They come up very often, but I don't know if they can be automated. The next part of the pipeline then tries to find inside those candidate routines segments that can be automated, that were really is deterministic to the extent that you could do them with a script. Yeah. And then I get routine specifications. Oftentimes you get too many routine specifications of that type. Some of them are very small. You want to merge them with others. Some of them are equivalent because there are many different ways of copying from this to this, right? You can start from first name, last name, etc. You might sometimes start by doing the address. You might sometimes copy the whole address and then delete the portion you don't want. Sometimes you just copy the part of the address that you want to take, and different workers will do it in different ways. So you will find out multiple routine specifications for the same routine. And you have to find which ones are equivalent and maybe merge them so that you don't produce a huge number of redundant routine specifications. You rather want a set of non-redundant routine specifications. And then this is the part that has interesting aspects from a research angle. Not less important, incredibly important, everything is important. is the engineering aspects. The first part, recording those UI logs, which is a tremendous engineering undertaking. Yeah, and the second part, which is once I have a routine specification, like this is a routine, like a sequence of steps, how to generate a bot in exactly the format that your favorite RPA tool uses. And for some reason, I don't have a favorite RPA tool, only a favorite process mining tool. But who knows, maybe at some point in time I will. So the first part of that pipeline is how to identify candidate routines for automation. And this is a very rich area for research and development. It's of interest both for researchers and is hugely of interest to tool vendors and users. So from the UI log, my take on it is that if you don't want to go completely nuts, you have to segment the log first. Yeah? Because taking 10 million, a trace of 10 million interactions of a worker for 5 hours is incredibly difficult to try to, it's like finding needles in a haystack. It's like very difficult to find a repetitive routine worth that is frequent in there. You can, but it has a very high level of complexity and you may end up with a lot of garbage. So the best thing is to try to find instances of tasks, like we do in regular task mining. We segment first, right? I could go and ask the user, how do I segment, right? And some users are patient enough that they will do it, probably because they are just paid for that. But in practice, if I would like to have a technology that really scales up and does not require to have analysts doing trial and errors to find the right way of segmenting, ideally I would like to find ways of segmenting automatically as much as possible. So I'm going to talk briefly about that. Then we segment, and then once we have segmented, we have not like 5 million events of a worker and 5 million events of another worker. No. For a given task type, we have all the executions of that task. So I says assess loan application. We have all the executions of the task assess loan applications. For every execution, we have a sequence of user interactions that were performed. So you have a collection of sequences, and identifying repetitive patterns in collections of sequences is a problem that has been tackled for the last, wow, I'm getting old. Probably I was going to say 20 years, but it's probably 30 years, right? Need to update myself. For the past 30 years, probably since the mid-90s, would that be 30 years, mid-90s? Yeah. Yeah, I think 30 years. For the past 30 years, it has been studied very intensively, and there are lots of tools for identifying repetitive patterns in large collections of sequences, traces. So first, we do a little bit of pre-processing because UI logs are pretty noisy. Stuff like, for example, you can see that in that first part that is highlighted, I can use my pointer. Wow, I can use my pointer. That's great. So in here, this, and this is not useful because at the end, what you do is you copy it from A3. The fact that in Excel, you visited 3 cells and then you copy it from the 3rd cell, the fact that you visited the first 2 cells is irrelevant because you didn't do anything with it. Yeah, it helps you because your fingers are moving, and that's good, right? But it's not very helpful it's not something that the bot needs to do, right? The bot can just go straight to cell A3 and copy from there. Yeah. Then there are other things like in here, for example, I copy from A3, I click somewhere, and I realized that I made a mistake. So I then went back and I copied again from A3, and now I paste. Well, the first copying and going to another field is not useful because I went back and I copied again, and therefore I overwrote the clipboard. So when I pasted when you paste only the last copy is important. The others get overridden anyway. So So we need to identify those redundant routines. We get rid of them. And that actually simplifies a lot your UI log. A lot of the things that we do are very repetitive. Who doesn't like, when you are tired to start just doing scroll down in Excel, to find your place instead of doing it very sophisticated and using shortcuts. So then you look at every UI and you separate. It's important to separate two types of parameters. There are some parameters whose value is different in every task trace. In one task trace, that parameter was Mike. In another one, it was Ron. In another one, it was John. In another one, it was Miranda. And these are names of people. For every task execution, the name of the customer is different, right? Whereas there are other parameters or columns in the UI log where you find the same values popping up. Like get cell, 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 get cell. Paste, 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 etc. Well, it turns out that those things that are coming up, those columns that are coming up, are most likely to be, are more suitable for finding patterns because they are shared across task traces, and probably that's your hook for identifying repetitive routines, and not that column that says Mike, John, etc., etc. That column is not a hook for repetitive routines. So you can, just by analyzing the columns, find out that probably these columns tell me what actions are being performed, and these columns are taking what are the data parameters of those actions in an automated manner without the user telling it to you. Of course, if the user tells it to you, so much better. Yeah, like in a process mining tool, you try to find which one could be the end timestamp, but if you can't, the user can just change it. Yeah, you try to find which one is the activity name, but if the process mining tool cannot, the user can override it. So we try at the pre-processing level to find which columns are likely action columns and which columns are data parameter columns. And then, given that, then we take the action columns, and the user can correct me if I'm wrong. These are the action columns. Like this is the column, click button, edit field, click button, edit field, click button, edit field. I project the traces over that column. For a moment, I remove the other columns. I just project them over that. And I can build a directly follows graph. By now, everybody should know what a directly follows graph is, right? If not, then you are well rested today because it means you slept the whole week. So you build a directly follows graph only on the, in this case, on the UI type column. I take the UI type column here and I take these traces. I group these by traces. I have already done my segment. No, sorry, I haven't done my segmentation. So I have a single trace of 5 million events. And from one single trace of 5 million events, I construct a DFG. That sounds completely crazy. Why would I construct a DFG of 5 million events? Well, that DFG contains loops, yeah? And guess what? Those cycles are very interesting because probably the scene inside the cycles are my task instances. Why? Because if I assume you are repeating the same task multiple times, you do loan application assessment for one loan application assessment later for another one, later for another one, later for another one, it's likely that you are going alike and you are coming back to the same place, which will be, for example, the button create new loan offer or create new assessment, for example. So you are probably doing stuff and coming back to the same place. So in that huge DFG, we can identify what we call the strongly connected components. So this is a strongly connected component in the sense that from every record you can go to every other record, and the strongly connected component algorithm was proposed by, anybody knows? Darjan, right, so you understood my tweet earlier this week. So we compute the strongly connected components. From there, we analyze every strongly connected component and we find the dominators. The dominators is like nodes through which you need to go to get to other nodes. And what we are after is for the header of those strongly connected components, which means the header of the loops. Those are the entry points. And also what we call the back edges, the longest back edges. And this guy is the entry point of a task instance, and this guy is probably the exit point of a task instance, the end of a task instance. So I try to find those entry point and exit points by finding the cycles, that's a strongly connected components, the biggest ones, and then computing with the dominator tree which one is the header and which one is the back edge. And then I know when an instance of a task starts and when an instance of a task ends. It doesn't work all the time, but when it works wonderful. So that is how we can identify the delimiters of a task instance. And once I have the delimiters, I just go and I cut. Yeah? So I cut, I say this is one routine instance, or a segment we call it. This is another routine instance. Why? Because it starts from click button, create new record, and it ends up in click button, submit all the time. Yeah. And that way I extract task instances and I have then segmented my event log. And once I have segmented the event logs, I'm almost done. I just now need to find the repetitive routines. As I said, so I have task instances. This is one task instance. This is another task instance. This is another task instance. And I need to find patterns in there. So for example, in here, you can see there is a pattern, U1, U2, U3, U4. And these UI, UX appear a little bit in a disorganized way. And they might be the TikTok thingy. Yeah? So these are candidates for being the TikTok thing, or I got distracted. And these are the things the pattern that really gets repeated across all the sequences. This is the pattern that gets repeated all the time. And these things in the middle are a little bit chaotic. So there are many algorithms that will find you this kind of patterns. So they are called sequential pattern mining techniques. And you will find a complete zoology of them. And we have tried several of them. And they kind of more or less all give you something very meaningful in terms of identifying routine instances. Some are a little bit better than others. So what we usually do is that we discover frequent patterns, and then we rank them according to a certain metric, the length, because we want to automate routines that are fairly long, the frequency, because we want to find routines that are very frequency, so more frequent, kind of better, and also something called the cohesion, which is I want routines that don't have many gaps. I assume that people don't do too much TikTok. So if I have a worker that does a lot of TikTok, then maybe it's not a good idea to use cohesion. But if I have like workers that are very focused, like you guys, yeah. So then it's pretty. Then I will have very little gaps in the patterns, and then a cohesion metric that measures how that gives preference to those patterns that have very few gaps in their occurrences. And from there, I come up with certain patterns that could be candidate routines, stuff that gets repeated very often, it is fairly long, and usually you do it in a focused manner. And there's an assumption in there that people do routines in a focused manner. They get rarely interrupted in the middle when they do a routine. Yeah? It might not be true for one particular routine, but on a large set of executions of a routine, say you dealt with 100 loan applications today, then usually this will work, and you will find the right routines. We did experiments with synthetic logs where we injected via simulation, we created logs where there was lots of stuff and a routine in the middle. And this technique was able to find basically in almost all cases, so a 0 is perfect. So it finds the routines exactly as we injected them. So it's capable of doing rediscovery of stuff that is already there. And then we created some real routines, and we executed them ourselves many times. We injected some noise into it, and we were able also to reproduce them with some imperfections. So there are some imperfections in this case. So 0 means perfect, and this is about 0.01, which is close to 0, and that meant that we're very happy that this technique can deal with noise as well. So you execute the same routine. This is now a person doing it, but then you inject some noise, and the technique is capable of handling this noise. And then we started composing like multiple routines together, because usually a worker will work on one routine, then another one, then another one, then another one, maybe in an interleaved manner. And there, of course, the performance is less good. So the learning is that if people are multitasking, this technique I presented will not work. But if people are not multitasking, and when they do a routine, they really do it, and from start to end, from start to end, from start to end, possibly with some distractions, then this technique for identifying candidate routines I presented is pretty good. We also applied it to real life. Now, real people in an admissions office at a university recorded for a whole afternoon, for example, about 4 hours of recording, and two people, one more junior, one more senior, and the junior person, of course, gets more clerical tasks, and we identified 2 routines using this technique I presented, and 5 variations of them, and we show them back to the person, and they say, yes, these are repetitive routines I do many times during the day, and gave some feedback, qualitative, that maybe the routines were discovered were pretty short, and she sees them as being longer than that. So she will not have split it in the same way, but the routines that we discover are the routines that this person believes are her repetitive routines. The more senior person, we didn't find any routines, and she claimed that what she does is not repetitive. So then it looks like we got it right. Well, it's not conclusive. I think what happens is that perhaps she does much more multitasking. Yeah, being a more senior person gets interrupted left and right, and possibly is working on 2-3 things at the same time. Somebody interrupts and she starts showing something, and then maybe we are not able to find repetitive routines, and she finds that her work is not repetitive. So okay, so this approach can work, modulo some refinements to identify routines in a non-multitasking environment and where it's clearly data transfer work happening. Now, imagine I have candidate routines for automation. This is very exciting. Is a routine automatable? Yeah? So then I say, what makes a routine automatable? We made many iterations and tried to put in one sentence. By the way, when I have a research problem, I try to say, let's not start working until we can spell out the solution in one sentence. Yeah? And the one sentence solution to the question, is a routine automatable, that we came up with is the following. A routine is automatable if every step, we call a user interaction, is such that this step can be deterministically executed given the previous steps, the data in the previous steps. So if all the data that I see in step number 10 can be derived from data I saw in steps 1 through 9, then the routine is automatable, or it's a constant as well. That's fine. It's either a constant or I can derive it from the previous steps, and that is true for every step in the routine. Then it's automatable, because I can do a bot. He does step 1. We know what step 1 is. Yeah, and there is certain data that comes out of it. Does step 2, and in step 2 there is either new data that comes up, so that's input, or if it produces an output, the output can be derived from the inputs it has seen before, and the same for step 3 and the same for step 4. I should be able to write a script to do that. So given an automatable routine, according to that high-level definition, we would like to produce a high-level routine script, a sequences of steps, described in a way that I can compile it into the code, a script of a software bot. That will then and it might happen that a routine is not fully automatable. Maybe there are some steps that are not deterministic. So depending, if I find them, maybe I should not discard entirely the routine, but I should rather tell you that this routine is automatable to 90% of its steps. Yeah? There are maybe 10% of steps that are not automatable, and we define the concept of a routine automatability index, which is the degree, the percentage effectively of steps or of outputs that can be derived, of step outputs that can be derived from previous step inputs. And that is an opening in case we want to do unattended automation, where you do not automate the entire routine, but you try to automate as much as possible, and when you get stuck, you hand off back to the user. So if the routine automatability index is 95%, probably this routine is candidate for automation. This having been said, from now on, I focus on the routines that are 100% automatable, so have a routine automatability index of 100%. So let me exemplify what is going on here. This piece of a UI log is deterministic because here I see something that is red, that's input. Then I see that copying is a reading operation, so it gets inputs. It doesn't have outputs. Pasting is a writing operation, so it gets an output. And I can see that I copied the same I saw before, so this step is deterministic. And the next step is also deterministic because once I have seen it many, many times, I will notice that this value can be derived from the other value by just trimming off the +6, the country code. The country code can be different depending on countries, by the way, but by just throwing the first token, I can derive the second token. So the question is, if I have deterministic routines in that way, how to detect them? And if I have them, how can I automate them? You know, in other words, how can I find these functions that go from this kind of inputs to this kind of outputs? So sounds like a difficult problem, especially that can get a little bit more complex. For example, here I have an address, right? And this address, you take different pieces of it and they copy it from to different fields. So the same input gets split into multiple strings. So it's a little bit of a tricky problem. Don't do it. Yeah. So, but we said, let's give it a shot. So, and we did it by using a technology called data transformations by examples. There are some people who have made their career out of developing techniques for discovering or synthesizing data transformations from examples. So people record examples of how to do it, and then they say, this is the data, this is the program that can do what you are doing automatically. So we mapped this problem to a data transformation. We from the routine instances, we map them into examples in the format that the data transformation by examples techniques needs. We then call, for each routine instance, then we do this. We say, let me see if I can synthesize a routine for, I go from the last one to the first one. I look for the write operations, like this edit field is a write operation. I look for all the previous reading steps, yeah? So then I say, this writing step most likely comes from this and this and these reading steps. So I read data and I wrote it here. And then what I'm gonna do, I'm gonna say, here's an example for this data transformation discovery problem. I have these inputs and I need to produce these outputs. Then I go backwards and I look at the next, this is one example of a routine, and then I keep going backwards. Most likely I will take this edit field next, and I'll try to find the corresponding copy steps, the reading steps, and I'll be the second example. This output was produced from this and these inputs. And then I go backwards and I keep finding all the writing steps and the previous reading steps and building examples. And And then I can give them to the data transformation by example program, except that I need to help my data transformation by example program a little bit. We need to apply a little bit of an abstraction step. You can see that these are the many different ways of writing a phone number. Yeah? And there's lots of variations, and you can probably invent more of them. So instead of giving this input to the data transformation by example, that will be probably it will fail because it cannot find how to derive the output from the input. I will help it a little bit by grouping the examples into different groups depending on the formats that are used. So we do a tokenization steps. You know, all the numerals, the decimals is one. All the alphanumeric symbols is another type of symbol. And we transform these kind of things into these kind of things. This is alphanumeric, this is decimal, and they're tokens. And I represent the example in these terms instead of that one. And then we group by this thing, which means that all the inputs that look like this, they go into one cluster. All the examples that where the phone number looks like this, they go into another bucket. All the examples that look like this go into another bucket, etc. So I divide instead of giving to the discovering data transformation from a single bucket, I discover data transformations from different buckets depending on what formats are being used in the fields. Yeah, depending what shape they have. And that will help my data transformation by example to be more accurate because it takes homogeneous input. I call it on individual buckets where the inputs have a very homogeneous format. And then this data transformation by examples can do marvels. There is a tool called FUFA that implements a technique for discovering data transformation by examples using an A-star algorithm. Roughly what it does is that you have to kind of tell him how to cut strings. It cuts the strings in different ways, and it tries to find splits and drops that allows you to go from an input to an output. And it tries to find the simplest split and drop. For example, to decompose these strings, it will split, it will take the first token out, and then it will drop it, and you get this output, which is the output I wanted. Whereas in this one, another possibility would have been to split into 4 tokens and then to drop the first one and then to join the second and third and then to join these ones and these ones together and you get this. This is a longer script or program than this one. This one is only 1, 2 steps. This one is 1, 2, 3, 4 steps. So it gives the smallest program that can do with splits and joins this transformation. And then I know then how to derive these transformations I show. So these techniques take care of syntactic transformation. You just copy it from here to here, or you split it and you copy it and you merge it with another one. It will do that kind of split, merge, copy, paste. Remains that sometimes there is semantics in your transformation. For example, it might be that you replace the country of residence by an abbreviation. DE for Germany. Is it UK for Ukraine, right? Yeah, UA. UA for Ukraine. Very sorry for that. UK must be for UK, I guess. And NZ for New Zealand, etc. Yeah. Or you can find mappings of the form. If it's Germany, it's international. If Australia is domestic, if New Zealand is international, etc., etc. So there is these mappings. Now, there is another technique. It's very funny. There is another technique that finds functional dependencies in a database. So it can find that you give him these examples in a way, and it finds the function, that goes from column 1 to column 2. that goes from Germany means international, Australia means domestic. So you give him a big data set of examples, and it finds the function for you, yeah, the correspondence. And that way, by looking at the examples and processing them using these functional discovery techniques, we can find these mappings where Germany has been replaced by DE and Ukraine has been replaced by UA. Provided that I have a large enough set of examples, I can find them. Then we combine these techniques, tokenization, FUFA, etc., and we find routine specifications. And then we have another technique. I will not enter into details to find some techniques, some routines that are redundant, meaning they do exactly the same thing. They just do the operations in a different order. And we merge them. And then we apply them more or less to the same benchmarks as before. And again, in the synthetic examples, we were able to find very high accuracy. This is an F-score kind of score, very high, as you can see. In the ones where we sat down and we record the techniques, we have a routine specifying high level and we just do it ourselves, each of the authors separately. We got also very high results. And then we started mixing and matching them, and the accuracy kind of more or less stayed well, provided that there is no multitasking. And we also applied it in the context of a real-world example. There is a tool called Robidium that we presented at the BPM conference a couple of years ago, that was 2020, that implements these techniques. You give him a UI log, it finds the candidate routines, it then shows them to you, and if you pick a routine, you say discover, and it generates the UiPath script. You load it into UiPath, and you get a bot that executes the routine that you selected. I think I'm running out of time, so I will not go through the details of the demo. Let's maybe rather go straight to something that will be of interest to you. This is a very exciting area. I don't know, I am very excited. In candidate routine discovery, there is a lot of challenges into how do you do this kind of pipelines when you have multitasking. Multitasking is a very nasty phenomenon when it comes to discovering repetitive routines and automatability, or when workers get distracted very frequently, like this senior university admissions officer, most likely getting distracted all the time, and or where routines are performed in a piecewise manner. One piece is done, then there is a pause, then another piece is done. That's a little bit challenging. How to discover executable routines where it's not just about copy-pasting, but someone sees here something and types it there. We call that copy typing. Yeah? You see something here and you type it there. The problem is that I don't see in the UI log, you did not click on this cell. You saw it, but you didn't click on it. So I don't have it in the UI log, and unless I have eye tracking to see that you saw there, I don't know where you saw. So it becomes a little bit more complex because I don't see in the UI log from where you got it, and that makes the problem more difficult to tackle. And then there is a lot of work around monitoring. Once the bot is deployed, monitoring it, measuring acceptance of the bot, measuring performance of the bot, measuring compliance or identifying miscompliance, that the bot is violating certain rules in the organization, etc., etc. So those are some of the open challenges in this field. And the slide deck finishes with a lot of references to different aspects, log recording, log segmentation, very active research field. Most of the papers, by the way, from 2019 to 2022, as you will see in all of them, candidate routine identifications, synthesis of executable routines, and finally, end-to-end process automation, which basically pieces together all these different fields. And now I think I really went over time, so I should be ashamed of myself. Thank you, and if you have any questions, we might still have time.
Okay, so thank you so much for the presentation and for the insight into this other mining technique. I am wondering right now about this example you had where you're extracting the phone number from different formats. And within that, I encountered something similar, and the first thing I thought of was regex, using regular expressions. Have you looked into this, and if so, why don't use regex?
We actually did use regex. So as a representation
Opposed
format.
to
Yeah,
bucketing, I guess.
there was a plus in here. Yeah. So A plus means an alphabetic character gets repeated. Yeah. But we use very constrained set of regex, right? And there are techniques indeed for discovering regex or regular expressions from examples. Fascinating area. We try to download all the tools. We try to contact all the authors. We try to apply all the tools. And it ranges from it doesn't work to it doesn't work in our examples, but of course in a toy example it works, to it never finishes. So it runs for eternity when you give him real world examples. Yeah. So bucketing was a technique that was sufficiently simple we could implement it, right, ourselves. And then we let the data transformation by example engine, which does scale up and does work, to do the rest of the work out of these basic type of tokens we find. And in many real applications, it's really about that. It's like you have numbers and strings, alphanumeric and decimals, right? With delimiters, with like special characters, delimiting characters. So it serves a lot of practical applications. But yes, there are techniques for doing regex. I think if we had more resources, more time, we probably would have taken the papers, re-implemented some of them, and tried to kind of scale them up and see if we can use them. So we were very tempted to use techniques for discovering regular expressions from sets of strings automatically. That, of course, yeah.
I have rather maybe more general question about your opinion about the future directions of process mining.
Of process mining in general.
Yep.
Of process mining in general. I think we need to definitely, the time when we have when it's the time to propose cool techniques is kind of getting to an end, right? So it's no longer about proposing, cool techniques for different problems, and I have this problem and I propose another cool technique to it. I think we need to, there's increasing demand for for using process mining in the context of process improvement, of process optimization. So it's really about finding certain types of process improvement objectives and process improvement questions. Like, for example, how do I maximize cycle time efficiency while keeping my costs as low as possible? And we need to go and discover ways of doing that. So I do see, for example, RPM as falling to a certain extent in that category of techniques because the output is directly usable for automating tasks, and if you automate tasks, then you get a benefit. There's measurable benefit. So it's a technique that is not far away from the use case that generates tangible benefits. Yeah. So if you talk about resource reallocation, like capacity planning, roster management, these are type of problems that have direct applications. If you manage to optimize work for use, then you get better cycle times with lower labor costs, for example. Versus, I am going to do a technique. Can I say trace alignment? Bowden is not here, right? So I can say trace alignment. Okay, so I'm going to do a technique for trace alignment that will help to improve a technique for automated process discovery that is going to help to improve the process model that I discovered, that is going to help to improve a user to understand where the problems in the process are, that will help that person to find some insights in how to improve the process, that will help the change manager to implement those changes, that will help the organization to reduce its cycle time. So these long chains, I think I will avoid them. Yeah, the time for them is kind of gone now. There is going to be more demand for getting closer to the output. Yeah, in that sense. Well, yesterday there was a talk by Lars, and I think we and others disagreed with 3/4 of what he said, but the other quarter was very, very good. Yeah.
Thank you very much.
On that note, let's thank Marlon again.